Okay, the next question. So if you observe the question, a single bolted. So what is meant by single bolted? Only one line of bolt is provided. Okay, a single bolted double cover butt joint. So we know the meaning of this line. So single bolted double cover butt joint. It means one line of bolt and then two cover plates are used to connect two members end on end. Is used to connect two plates which are 8 mm thick. So now the main plate thickness is 8 mm. So next line, assume 16 mm dia bolts of grade 4.6. So here the dia of the bolt is given and its grade is also given. So which grade is used? And cover plate to be 6 mm thick. Okay, that is also given. Next, calculate the efficiency of a joint. So he's asking us to calculate the efficiency of the joint. So once tell me or once think what is efficiency. So what is efficiency we have discussed? So efficiency is nothing but it is a ratio of strength of the bolted connection by strength of the main plate. Agree or not? So that is what he's asking us to find in this question. So calculate the efficiency of the joint if 4 bolts are provided. Okay, if 4 bolts are provided in the bolt line at a pitch of 45 mm. So assume the grade. So one more thing that is given here is assume the grade of the steel. So if it is not given also we know that. So assume the grade of steel Fe410 and here the Kb value is also given. So if it is not given we know how to calculate. How to calculate Kb value? Come on, tell me. So how to calculate Kb value? So Kb value is a minimum of E by 3dh comma P by 3dh minus 0.25 comma Fu by Fub by Fu comma 1. Out of these whichever is minimum that we should take it as Kb value. So that is given here. And one more thing it is mentioned, thread intercepts shear plane. So that is given in the question. Now he is asking us to find efficiency. So first let us draw the diagram. So first let us see the diagram and then we go for the calculation. So we see both top and front view. If you see the diagram, so these two are the main plates connected end on end. So by using a cover plate, so we have connected these two single bolted. It means only one line is there. And the thickness are given. So how much this thickness? 8 mm. So how much this thickness? 6 mm. And pitch is also given. Okay. And one more thing here. So this is about the diagram. Let us see the top view. So this is front view. So in front view we can see the length and thickness. In top view we can see the width and thickness. Okay. So in one line how many bolts are there? 4. That is mentioned in the question. So now pitch is given is 45 mm. So it is a distance between center to center. But I am going to consider like this. See here, this is center to center and this is center to center. So I am going to consider from here to here. Now tell me, this is also considered as a pitch, yes or no? Yes or no? So from this center to this half of the pitch and from this center to center half of the pitch. So total pitch. So how much it is given as 45 mm. So now width is not mentioned in this question. So now I am going to calculate the design strength per pitch length. So in this question I am going to calculate all the design strength for pitch length. So far what we have calculated is for total width or total. But here I am going to consider for only pitch length. Why? Because the width is not given here. Clear? So first take down the diagram and take down the question also. I am going to write the question. So bolt dia is given as 16 mm. So now it means dia of the bolt hole is 18 mm. Clear now? And it is 4.6. The bolt of grade 4.6 implies FUB is 400 MPa. And FU 410 is given, implies FU is equal to 410 MPa. So these are some given information. The remaining we have shown on the diagram. So now let us calculate design shear strength of bolt per pitch length. Per pitch length. What is the formula? FU by root 3 into 1.25 into area. So it is mentioned that to take or consider threads intercept shear plane. If thread intersects shear plane, then we have to take the area as 0.78 into pi by 4 d square. And that too, the rivets here in double shear. So 2 pi by 4 d. So d is how much? 16 into 0.78. And here how many bolts that are there in this pitch length? Only one bolt. So if you observe how many bolts are there in this pitch length? So that is a pitch length. So in pitch length, how many bolts are there? Only one bolt is there. So consider only one bolt. So come and calculate how much it is. FUB is 400. So 400 by root 3 into 1.25 into 2 into pi by 4, 16 square into 0.78. So it comes out to be 58 kilonewton. It comes out to be 58 kilonewton. So next, design bearing strength of bolt, again per pitch length. So what is the formula? 2.5 kb So D is how much? Dia. So dia is how much? 16 mm, and T is the thickness, minimum of sum of the cover plate thickness or main plate thickness. So this is the cover plate thickness 6. So sum is 12 and here it is 8. So minimum is 8. So take it as 8. So regarding this kb, it is also given in the question. How much it is given in the question kb? So in the question kb is given as 0.55. And FUB we know that 400. And D how much? 16. T how much? 8. So everything is known. Upon calculating, we are going to get it as 56.3. So this is the bearing strength. So far we are discussing the strength, or we have calculated the strength based on shear and bearing. That's it. So now this is out of these two, whichever is minimum, that is considered as a strength of that bolted connection, which is minimum. So this is minimum. So now strength of bolted connection is how much? Our strength of the joint is 56.3. Now let us calculate the strength of the main plate. Design strength of the main plate. So design strength of main plate, the formula again, strength is equal to area into permissible stress. So here permissible stress to be considered as 0.9 FU by 1.25 into area. So the area which is undergoing tension. So this is the width and thickness. So this is the width and thickness is perpendicular to the board. So how much? 45 into 8. So if you see, this is plate. So we should not write 400 here. We should write 410. So 0.9 into 410 into 45 into 8 by 1.25. So how much it is? So it is comes out to be 106.27. 106.27 kilonewton. So this is the strength of main plate, design strength of main plate. Now we know that efficiency. So efficiency is nothing but strength of the bolted connection by strength of the main plate. So how much the strength of the bolted connection it is? 56.3. And bolted and the strength of the main plate is 106.27. So to express in percentage, we have to multiply with 100. So finally, how much we are going to get the answer? Which option we are going to get out of those 4 options? We are going to get it as 52.99. It means second option we are going to get. So this is how to calculate the efficiency of a bolted joint. So take it down. Is it clear, everyone? So this is how to calculate the efficiency of the bolted connection or bolted joint. So first we have to find out the strength of the bolted connection or joint, and then we have to calculate the strength of the main plate, and we have to divide these two. So it is a ratio of the strength of the bolted connection to the strength of the main plate or main member. So the strength of the main member is to be calculated like this per pitch length. So here we are calculating per pitch length. So per pitch length here, how many bolts are present? Only one. See, for example, everyone listen. So for example, if it is in the given question, it is mentioned that it is double bolted, double cover butt joint. So double bolted means 2 lines. So here 2 lines means here how many bolts are present here? Like this. So now how many bolts are present per pitch length? 2. So everywhere we have to multiply with 2 here. So if it is a double bolted, double cover butt joint, so in this question it is mentioned that single bolted, it means only one line of bolt is there. But if it is mentioned that double bolted, double cover butt joint, then 2 lines of bolts are there. It means here how many bolts are there per pitch length? 2. So in all these formula we have to multiply with 2. That is the difference. So as we are calculating for pitch length, so we have to consider per pitch length how many bolts are there. That's it. So take it out. So this is no need to consider this. Why? Because in this question it is given that single bolted, double cover butt joint. Okay, so this is about the design of the bolted connection. So that too, strictly speaking, so far whatever we are discussing regarding the bolted connection is only concentric bolted connection. It means, what is meant by concentric bolted connection? The CG of the bolted group or bolted connection and the line of action of external load is passing through the same line, or they are coinciding. Okay, the CG of the bolted group or bolted connection and the line of action of the external load, if they both passes through the same line, or if they both exist on a same line, then that is known as concentric connection. So now so far whatever the connections we have discussed is concentric bolted connection. So this is the design of concentric bolted connection. So this is finished. So now let us see the next topic. So first you take it down. So is it clear, everyone? How to design or how to calculate the concentric bolted connections, everyone? So take it down. So we'll start the next topic.